Good morning. I've been working on this 3D printer board. I've chosen CH32 307 model with a RISC-V variant. From IWCH they have ARM and RISC-V cores. So this board is a 3D printer dedicated. We have 5 channels of stepper driver, 24 volt 2 amps. We start from 24 volt. We make 7 volt and 3.2 volt rails. We have 8 make crystal, the microcontroller, ROHM drivers, BD63521 drivers, which are nice and tiny, and we have set up all the control pins of them for the microcontroller to tune the control mode, decay mode, current. Actually, I'll change that so that just signal enable is an override, an external override, and the override will place on a test point at them. We have all our test points over here, fiducial and mounting holes, and the terminal blocks for the motors, power supply. We have protection fuse and protection diode. Those diagrams are work in progress. I need to add the inputs for the printer's limit switch, LCD driver as well. We have a look at the PCB layout, and we see that the parts that finished is a microcontroller and 1 driver channel, and the clock remains to be done all of the parts. I'll provide a follow-up on this project as well. The board is fairly simple, so the stepper driver need only shunt for current measurement on the phases. They need a 24 volt power supply, bypass capacitors for the power supply. Enable and power save are used to connect or disconnect the motor output, and also to place the chip in a off mode. Apart from that, we can control the micro steps with mode 0, mode 1, and decay mode. The decay mode is part of the stepper ramp down on the current. For the decay mode and current reference, I have made these PWM signals with RC filters so that we can tune the stepper driver reference current or maximum current, and the decay mode is an analog signal as well. We see that on the microcontroller side we will be able to change the boot mode. The boots are set on test point, can be used for development. We see that we have serial communication through a USART over here. We have programming and debugging over here, SW signals. We have low speed and high speed crystals. The low speed will be able to provide a real-time clock for some purpose if we need it. The reset, power save and enable with external override, mode control for the driver, bypass capacitors everywhere, and controls for all the pins on the motor drive. So the board is not complicated. We need to add the drivers for the heaters, inputs for temperature, LCD driver as well. So the schematics are about 70%. I hope you find this interesting if you learn how we can design such type of... And I present in the future the resulting PCB firmware tests when this project goes to a mature finished product. So the goal is to implement Marlin Firmware on this microcontroller. I believe Marlin Firmware will need modifications to it because it doesn't support RISC-V, actually this specific microcontroller, as long as I've seen. So some new implementations for the stepper driver control will be needed on the firmware side. Thanks and good evening.